volcanic hotspots and continental drift. In this workshop, real geologists share the stories of how they became geologists and how their work requires them to travel to interesting locations. They explain how an understanding of mathematics is integral to the work that they do in the field. They also describe how much of their work is based on theory, but that theories are not always perfect, such as the case in this workshop. The field of geology is the study of the composition and processes of planet Earth. Specifically, this workshop demonstrates how hotspots can be used to analyze the movement of tectonic plates. Hotspots are anomalies in the Earth's crust that slowly lead to the creation of volcanic islands. The Hawaiian island chain is an example of volcanic islands that have formed as a result of a hotspot. Using mathematical modeling of the Hawaiian island chain, we can explore the movement of the Pacific tectonic plate. This workshop could be linked to geography, history, and science, or specifically, earth science contexts. Students see how real data can be collected and analysed to support scientific investigations. The position of the islands, along with their age, is used to evaluate the movement of the tectonic plate. Students use the plotted data to explore reasons behind the development of the Hawaiian island chain. Students work in small groups, measuring distances from the map and plotting the points graphically with the age of the islands. The students need to take into account the scale of the map and consider ages in millions of years before graphing their data. This activity has students employ a line of best fit and explores the significance of the slope of a line in a real-world context. This also gives the students an opportunity to make sense of the idea of tectonic movement as they establish the speeds of the tectonic plates. The large distances and time frames force the students to engage with numbers beyond their normal day-to-day interaction, testing the quality of their mathematical understanding in unfamiliar contexts. The final stage of the workshop requires the students to apply some higher-level analysis as they aim to reconcile the graphical data with the positioning of the island chain on the map. There is an interesting twist in the story of the chains of islands that makes the students question their first impressions. The twist highlights the constructivist nature of science, as the evidence does not support a clear theory. The workshop uses only one case, but others exist which could be used. The workshop scenario requires the students to move beyond their comfort zone and apply complex critical thinking. It introduces concepts that will be developed further at school and become significant in senior school. The complete workshop would take 2 or more hours, but it can be broken into sections. Depending on the student cohort, additional time could be used to allow the students to further explore some of the non-mathematical concepts. A fun option is to ask the geologists to perform a demonstration where liquid nitrogen is used to build up pressure within a pre-dug hole, leading to an explosion of stress balls.